All right, welcome back, boys and girls. Today we are talking about another topic, which is going to be exponent and logarithmic laws. And then next videos will be about equations regarding exponents and logs. So far, if you haven't checked out the videos previously uploaded, I have videos about arithmetic and geometric sequences and series. So if you need them, if you covered them at school, make sure you check them out. But today and next few videos is going to be about mainly logs, but we have to refresh some exponents because exponents and logs are basically evil twins, right? They are kind of undoing each other. If you have done calculus before, this is like a derivative and antiderivative, which is an integral, right? One undo the other one, or one undoes the other one, if that's a word. Okay, so I'll start with the exponent laws. This is theory video. I'm planning to keep it very short. I'll do some examples on this one as well, but then there will be another video where you can do only practice questions. So if you're familiar with the theory, you don't have to go through this. You can jump to the video where you can practice more questions, exam-like questions. All right, so what do I want to talk about in exponent laws? Now, like I said, exponents and logs are very similar, so we need to have good foundation on exponents. So let's start with some basic stuff that we already know. In the next few questions, I will put it on the side where we can actually refer to it, because we might not have to memorize them. Although exponent laws you have to memorize, because in the formula booklet you only get equations, you get formulas for logarithmic laws. So what do we have? Let's start very basic. A to the power of 0 is equal to 1. So anything to the power of 0 is 1. It doesn't matter if it's a polynomial, if it's a single thing, if it's a number, doesn't matter. Anything to the power of 0 is 1. Anything to the power of 1 is itself. Okay. If you have two exponents, let's say a to the power of b times a to the power of c, if the bases are same, what do? We just add the top. So a to the power of b plus c. If we have a similar style but division, a to the power of c, this time we just subtract them, right? If we have a bracket, meaning a to the power of b to the power of c, when we open the bracket, we don't add b and c, we multiply them. So it becomes a, b times c. Okay, what else do I want to mention? If you have two exponents, a, b, and let's say, what else can we have? C to the power of b, meaning that the bases are not same, but the exponent part is the same, then the answer is going to be a times c to the power of b. Okay, I think that's all in terms of exponent laws. Let's do some examples. I put it here on the right side for you to check out. I think we might have covered everything, but maybe not actually. There's a power rule we talked about, product rule. Okay, when you have a bracket, when you open them, you apply the power to every single one of them. Yes, negative. We didn't talk about negative, yes. So if you have a to the power of negative m, that's going to be 1 divided by am. Okay? And also I saw there was something about the square root. So you have square root of, let's say, a, that's equal to a 1 over 2. Or if you have m a n, this is going to be equal to a n divided by m. This actually comes pretty often, so we should get comfortable with that. So it's here for us to check out until we memorize them. So let's do some examples. Okay, first one, what do we have? We have 3 to the power of 2. Let me put here first one. I'll just put equal as a continuation of that. So, or maybe it's better to write it so it's not confusing. Times 2 to the power of 3. So there is no same base, there is no same exponent. I don't think we can actually write it using the exponent laws, so which is fine. it's good to be able to identify them. So first one is 9, second one is 8, that's going to be 72. So that's enough. 2, let's go down. 3 to the power of 0 plus 0 to the power of 3. Now we learned that 0 exponent rule right here, that anything to the power of 0 is 1. So this is going to be 1 plus 0 to the power of anything is 0. So that's going to be 1. 3, 5 times 3, negative 3. Okay, the bases are same. I'm checking what? I'm checking my product rule up here. And I add the top. So 3, 5 plus negative 3. Make sure you don't make a mistake with the signs. It's very important. 3, this will be basically 5 minus 3. And 3, 2, which is 9. 4, we got 5 to the power of 4 times 2 to the power of 3, 2 to the power of 2 times 5 to the power of 3. So that's going to be what? So we see that there's some common terms, right? We can group 5s together and 2s together, right? So I'm going to actually write them here so you can see it. I wouldn't do that in the exam or anywhere else, but just because we're just learning or reviewing. So 5, 4 and 5, 3. Their division, quotient rule, you check out on the table here. We subtract the top, so 5 to the power of 4 minus 3, which is going to be 1, and we don't write 1, so it's just 5. And again, same deal here, 2 to the power of 3 divided by 2 to the power of 2. 3 minus 2 is just going to be 2, so the answer is going to be 10. I still have a little bit of space here. I might do the last one on the actual table, but let's see. 3 to the power of negative 5 times 3 to the power of 3. This one is simple. The bases are same. Again, we can use the product rule, which is going to be 3 to the power of negative 5 plus 3. And that's going to be 3 to the power of negative 2, which, using the negative exponent rule, we can write it as 1 divided by 3 to the power of 2, which is also mean 1 divided by 9. Okay, and the last one, I kind of run out of space. So we have all 7s here, so this should be easy. I can use the product rule on the top, which will be 7. 4 plus 2 is 6. And at the bottom I have 1 and 7. If there is no exponent written, that means 1. So 1 and 7, that's going to be 8. And 6 divided by 8, we subtract them based on quotient rule, and that's going to be 1 and 7, 2. Or you can also write it as, if I have a little space, 7 to the power of negative 2. Again, based on the negative exponent rule. So that's about a little refresher for exponents. Now let's move into some log rules. So, again, like we said, logs are undoing what exponent does. So the very basic thing in log is this: log AB equal to C. I always tell my students to remember this one, understand this one, right? Now, this is a log version. If we get rid of the log, this will become, B will become A to the power of C. Okay, so the one on the right side is without a log, as you can see, the exponent version, and the one on the left is with the log. So what is the example of that? Log 8 is equal to 3, meaning 8 is equal to 2 to the power of 3. Okay? So, there's a lot of applications of logs actually, which we will see later, but if you're curious, they can be applied to any exponential growth type of situation. It could be decay, it could be something, how much something will increase over time or decrease over time. There's also application of logs in calculating pH levels, and if I'm not mistaken, also earthquakes. If you're curious, you can maybe watch a couple videos about that, about the real-life application of logarithms. Okay, so in terms of laws, so this is, you can think of it, first law. Okay, but then there is more to it. There is more to it. For example, I think this is called product rule. So log, actually before I do that, actually let me mention a few things. So log a1 is equal to 0. Why? Because anything to the power of 0 is equal to 1. So you can remember this one. Log AA is equal to 1. Again, why? Because a to the power of 1 is equal to a. These are basically exponents in the log format. We cannot have log a0 because nothing to the power of a positive value will be 0, or actually negative value, it doesn't matter. Unless it's 0 and the base cannot be 0. But we'll about that later. So sometimes you will see that log doesn't have a base written. For example, they will say log 5. That means the base is 10. Log 10, 5. Also, you will see in some cases there's ln, which also means log base e. So ln 5 means log base e 5. Okay. Now about the rules I meant. So these are also rules, but you know, a bit basic rules. Now product rule: log ab plus log ac. So bases should be the same. If you're adding them, then it will become log a, base stays the same, b times c. Now, when you're subtracting them, however, we do division. So it becomes log a, b over c. Okay, these are used quite often. Let me just complete that in case somebody gets confused. Log a, c. Okay. So what else do we need to know? We also have change of base, but I kind of run out of space. So maybe we can look at it in the next page. Okay, I put some examples here, but I also put the change of base rule on the... This is from the SL formula booklet, probably HL as well. AA, HL, SL. So, let's see. Let's try to apply these rules. I will also explain the change of base at the end of this slide. So, first one says log 10, 10. Okay, again, we have, like we said, we always come back to this. Log AB is equal to C, which means B is equal to A to the power of C. So, for the first question, log 10, 100, we know our B, which is 100. We know our A, which is 10. We don't know our C, which is X. Right? So, what 10 to the power of something equal to 100. What is that something? That something is 2. You don't have to guess it. You can also write 100 as 10 to the power of 2 and equal to 10 to the power of x. And from here you know that x needs to be 2. Second one, log 10, 50 plus log 10, 2. Now what does that remind you of? It reminds us the product rule. The first one right here on the formula booklet. So it will be equal to log, base will stay the same, and here we'll have 50 times 2, which is log 10, 100. Can we leave it like that? Sure, but are we going to? No, because we know that log 10, 100 is 2. We just solved it. Okay, and the last one, log 10, 4 minus log 10, 40. When we subtract, we use the quotient rule, which is the second one right here, division. So it will become log 4, and here it will be 4 divided by 40, and that will be log 4, 1 over 10, which, sorry, not 1 over, yes, it is 1 over 10. The base is 10, not 4. Yes, 10, 1 over 10. Now 1 over 10 is basically 10 to the power of negative 1, so this is going to be negative 1. If it doesn't make sense, think about it for a second. Okay, so log 10, 10 to the power of negative 1. This is basically what we have, equal to whatever, x, right? And then you can write 10 to the power of negative 1 equal to 10 to the power of x. And from there you know that x is going to be equal to negative 1. Now the last piece here, the change of base, which I said I will talk about, it says log BA is equal to log CA divided CB. This is when we use it, this is what we use when we are dealing with logs that have different bases. Now, we can't really use product rule, we can't use, let's say, quotient rule, so we have to, it's like bringing common denominator for fractions. You bring them into a common base, and then you can apply your rules. So we'll have in the practice section, we might have some questions about that. Okay, but that's all I want to cover for this video. A little bit of recap of exponent laws and logarithmic laws. In the next video, make sure you do some examples, and I will see you guys later.